Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's presentation on Sampling Distribution Part 3. Let us recall the previous session. In the last session, we have discussed about the sampling distribution of means. In that again two types, sampling distribution of means sigma known and sampling distribution of means sigma unknown. And again for finite and infinite populations, we have discussed about the sampling distribution of means. Now coming to the today's session, today I would like to solve some problems on sampling distribution where sigma is known. Now let us consider the present problem. Problem number 1. A population consists of 4 numbers 2, 3, 4 and 5. So the given size of the population, given size of the population, the population consists of 4 numbers, so capital N equal to 4. And what are those elements? The elements are numbers 2, 3, 4 and 5. Next, consider all possible distinct samples of size 2 with replacement. Let us consider all possible samples of size 2 with replacement. Then find the population mean, population standard deviation, sampling distribution of means, mean of sampling distribution of means and standard deviation of sampling distribution of means. So from the given population, first we need to draw the samples of size 2 with replacement. That means each member of the population can be selected more than once. We can select the number twice also. So here first, coming to the first one, the population mean. Since the population is having 4 elements, the mean of the population denoted by mu is given by sum of those 4 numbers divided by total number of elements. So 4, which is 14 divided by 4. So which is equal to 3.5. So the mean of the population is 3.5. Next, coming to the second D bit, the population standard deviation. So to find the population standard deviation, first we find the variance sigma square. What is the formula? Sigma AI minus corresponding mean whole square divided by total number of elements, capital N. AI are the elements of the population and mu is the mean of the population, and the sum of the squares of deviations of the elements of the population from the corresponding mean, that is variance. First we find the variance, then standard deviation is the positive square root of variance. So let us calculate this value first. So sigma square is equal to, from each individual value 2 minus subtract this mu 3.5, 2 minus 3.5 whole square plus 3 minus 3.5 whole square plus 4 minus 3.5 whole square plus 5 minus 3.5 whole square divided by how many elements are there? 4 elements. So this value is, after simplifying and using the calculator, we can find this value as 1.25. So sigma square is 1.25. Now after getting this variance, the standard deviation of population is sigma under root 1.25, the positive square root of variance. So root 1.25 is 1.118033. So this is the standard deviation of the population and mean is 3.5. Now, coming to the third one, see bit, the sampling distribution of means. First, we have to find the sampling distribution of means. And what is the size of the sample here? Each sample must be of size 2. So, consider all possible distinct samples of size 2 with replacement. So, given population consists of 2, 3, 4 and 5, then the samples of size 2, drawn from the above population are given by, now let us consider the element 2 from the population, and here the question is regarding with replacement. So, after selecting the element, again we can replace it back. So, again I can select the same number. So, 2, 2 is one of those samples. Similarly, let us fix 2 and change the next number, 2, 3, 2, 4, then 2, 5. Similarly, you can find the remaining samples from the given population by selecting the elements in the similar way. So, here 2, 2 is possible since the element 2 can be replaced it back in the population. So, again we can select it back. Now, the remaining samples are, let us fix the first element as 3, 3, 2, then 3, 3, then 3, 4, then 3, 5. Next, again we are replacing the elements in the population. So, I can start from 4, 4, 2, 4, 3, 4, 4, 4, 5. Now, fix the first element as 5, 5, 2, 5, 3, 5, 4, 5, 5. So, these are the possible samples of size 2 with replacement. Total number of samples 16. So, total number of samples is equal to 16. Now, we need to find the sampling distribution of means. That means, we need to find sample mean of all these 16 samples. So, the corresponding sample means are given by, now what is the mean of 2, 2? 2 itself, 2 plus 2 by 2. Similarly, 2, 3, 2 plus 3, 5 divided by 2, 2.5. 2 plus 4, 6 by 2, 3, 3.5. Similarly, 3, 2. So, 2.5, 3, 3.5 and 3, 5, 8 by 2, 4. Then 4, 2, 6. So, it starts from 3, 3.5, 4, 4.5. And last row 5, 2, 7. So, 3.5 average or the mean, and 5, 3, 4, 4.5 and the last one is 5. Now, the set of these two values is called the sampling distribution of means. That means the sample and corresponding mean. Since here there are 16 samples to show this sampling distribution in the form of a table, the values are 16, more number of values. So, instead of that, let us construct the sampling distribution as the sample mean and the frequency. For example, what are the possible values for this sample mean? 2 is one of those possible value, 2.5 is possible, 3, 3.5, 4, 4.5, 5. These are the different values. So, 2, 2.5, 3, 3.5, 4, 4.5 and then 5. And mean 2, how many times repeated? Only one time. So, it is not repeated value. So, 1, frequency 1. But 2.5 is repeated twice. So, 2.5 2 times. 3 times, then 3.5 4 times, 4 3 times, 4.5 2 times and 5 1 time. So, we can represent the sampling distribution of means in this form also. Otherwise, how to represent the sampling distribution? The samples, first sample, second sample, third sample, like that, 15th sample, 16th sample. Then corresponding means. First sample mean is 2, second is 2.5, third is 3 and so on. 15th is 4.5, 5. Like this, we have to construct the table with 16 values. Either we can represent the sampling distribution either in this form or else in this form using a frequency distribution table. This is called sampling distribution of means. Next, so the third one is over. Fourth one, the mean of sampling distribution of means. So, we have to find the mean of sampling distribution of means. Mean of sampling distribution of means, which is denoted by mu x bar. So, this mu x bar is given by sum of all these means divided by total values. But since it is a frequency distribution table, the 2 is repeated one time, 2.5 is repeated 2 times. So, sum of the products of these values. Mu x bar is given by 2 into 1 plus 2.5 2 times, next 3 times, 3.5 4 times, next plus 4 3 times, 4.5 2 times plus 5 1 time. This whole divided by total how many values? Total frequency is 16. There are 16 values. So, sum of the products of these values divided by total number of values 16. And here by simplifying this value we will get mu x bar is equal to 56 by 16, which results as 3.5. And here we can observe that the original mean of the population is 3.5 and mean of the sampling distribution of means is also 3.5. So, from this, hence this mu x bar is equal to mu. This is one observation. Now, similarly, in the last question, so this one is over. In the last question, we have to find the standard deviation of sampling distribution of means. To find that standard deviation of sampling distribution of means, first let us find the variance of sampling distribution of means, which is sigma x bar square, sigma square x bar. Sigma square is the variance and its positive square root is the standard deviation. And what is the formula here? Here the formula is sigma from each individual elements, for example ai, minus corresponding mean mu x bar whole square by 16, total number of elements. So, from each individual, again go to the sampling distribution of means. From this table, 2 is repeated one time. So, from 2 subtract the corresponding mean 3.5, which is repeated one time. So, 2 minus 3.5 whole square plus, again go back, 2.5 is repeated 2 times. So, subtract 3.5 from 2.5 and multiply it with 2 times because the value is repeated twice. Similarly, the third value 3 is repeated 3 times. So, 3 into 3 minus 3.5 whole square plus so on, like that. The last value 5 is repeated only one time. So, 5 minus 3.5 whole square total divided by 16. This gives the variance of standard sampling distribution of means. After simplifying this, we will get sigma x bar is 10 by 16, which is equal to 0.625. This is the standard variance of sampling distribution of means. Now the standard deviation of sampling distribution of means, sigma x bar is the positive square root of 0.625, which results as 0.7905694. And here also we can cross check. This case is with replacement. So that means the sampling is done from infinite population. So sigma x bar and sigma by root n, these two values will be the same, 0.790564. So like this, using the given data, the population elements, first we form the sampling distribution of means, then we can find the mean of the sampling distribution of means, and then the standard deviation of sampling distribution of means. Similarly, let us consider another problem, problem number 2. The same question let us solve without replacement. So you see here, a population consists of 4 numbers 2, 3, 4, 5, and consider all distinct samples of size 2 without replacement. So without replacement we need to consider the samples, then find population mean, standard deviation, all the same. So here the first question and second question are the same. The population mean mu is 3.5 and sigma, the standard deviation is 1.118033. 1.118033. These two are common for both problems. Now coming to sampling distribution of means in without replacement. So population consists of 2, 3, 4, 5 and the sampling is done without replacement. So that means when I select an element from the population, I am not replacing it back. So each element of the population can be selected exactly once. So therefore, the possible samples of size 2 without replacement are, for example, let us fix 2. So I am not replacing it back. So the element, the sample will be 2, 3. And here 2, 2 is not possible as I am not replacing the element. Next, 2, 3 is over, 2, 4, 2, 5, 2, 6, yeah, okay. Next, 3, 4, 3, 5, then 4, 5. So these are the possible samples in the case of without replacement. So total number of samples are 6. And now first we need to find the sampling distribution of means. So we have samples, as the samples are only 6, we can consider directly 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5 and corresponding means 2.5 here, 3, 3.5, again 3.5, 4, 4.5. So this is called the sampling distribution of means. Now for this sampling distribution of means, we need to find again mean. So mean of sampling distribution of means, mu x bar. So for all these 6 means, again we need to calculate mean. So 2.5 plus 3 plus 3.5, again 3.5 plus 4 plus 4.5 divided by 6. We know that in both cases the mu x bar will be the actual mean. So after finding this value, you will get 3.5 and mu x bar is equal to mu itself. Similarly, standard deviation of means. sampling distribution of means. So, sigma x bar is how much? Sigma x bar is how much? To find sigma x bar, first we have to find variance. Variance of sampling distribution of means. So, sigma x bar, sigma square x bar, which is sigma ai minus from each individual subtract the corresponding mean whole square divided by total number of elements. So, the sum of the squares of deviations of the values from the corresponding mean. So, here each individual 2.5 is there, minus 3.5 whole square plus 3 minus 3.5 whole square. Like this, the last value is 4.5 minus 3.5 whole square whole divided by 6. And the result here is 0.4166. This is the variance of sampling distribution of means, and the standard deviation of sampling distribution of means. This is the required one to calculate sigma x bar, which is the square root of 0.4166, which results as 0.645497. 645,497. And again, here we can cross check the conditions as mu x bar equal to mu, and sigma x bar will be sigma by root n into sigma by root capital N into capital N minus small n by capital N minus 1. So, we can cross check these two values will be the same. So, this is in the case of without replacement. As we are replacing the element back, there are only 6 samples are possible, and form the sampling distribution of means, then find mean of the sampling distribution of means and standard deviation of the sampling distribution of means. Now, in today's session, we have solved the problems on sampling distribution of means when sigma is known. In that, again, we have solved 2 problems. One is with replacement and without replacement. In the next session, again, we continue the same. I would like to solve 2 more problems, solution of problems in sampling distribution of means using the known formulae that we are going to discuss in the next session. So, this is for today's session, and we will meet in the next session. Thank you.